No. It just has to be an example. Wait. I'm going to do an example right here. There's lots of examples in your textbook. They'll say, do you have a pass? You got to go get one. You probably have to go to student services. Check in. Like go to the lunch, like you're going to lunch, but don't go to lunch, go right, go into the office. If you see a dean along the way, they'll give you one. Thanks. All right, so this was your homework. These have some passes and fails. This one is an example of a fail. So this is not a function. And this is a pass. So this is a yes function. This is a fail, not a function. And this is a pass, yes function. So like, I'll show you exactly where it fails. So this one fails, like if I draw a line here and the line hits twice, it's a fail. On this one, if I draw a line here and it hits 2 points, it's a fail. On this one, I could draw a line through every single point and it would only ever hit once. So that's a green light pass. Same thing here. I could put a line anywhere and it would only hit once. That's a pass. So I'm going to go ahead and create one. Here's an example of a pass, and yours could look like anything. And here's an example of a fail. That's a pass and a fail. You guys can go ahead and get out your homework. Since I already put all the answers up there. Oh, it's supposed to say yes or no. Any questions on homework? Check your answers. Check your answers. Any questions on it? No. Okay. If there's no questions on homework, you guys are going to go ahead and flip to chapter 3.2. It's page 187. I'm going to while you guys are reading. I'll tell you. All right, you guys are reading page 183 through 190. It is going to be silence reading time, okay? As you go through, answer the questions. If you're off task or talking, you will not get credit for today's words. You're doing all of the gray boxes through number 7. You're doing 1 through 7. Read and answer it. Do numbers 1 through 7, but definitely take the time to read it if it's going to make any sense. Yeah. 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 Say whatever you want. Number 7's on 191. Thank you, Sharika. That's the kind of help I'm looking for. Thank you. That's productive cooperation. That's it. We're turning it around. All right, get to work, you guys. You're gonna read it and you're gonna try it. It might not make sense to you, but I'm not answering any questions for like 20 minutes of silence. You do your best to learn it. What I've heard from you guys is that you guys can figure this out pretty much on your own. You don't really need me that much. So you guys go ahead, read the book, figure it out. In 20 minutes, I'll answer a question if you have one. Maybe you don't have one. What's your question? Yes, do your best to answer everything in there. Yes. No, do your best, guys. Fill out your book. Read it, fill it out, interact with it. Do your best to understand it. If you simply can't, go on to the next section. Yes. You already went murder. As you flip through, you'll find that. If you can't figure it out, go to the next section. You try everything for 20 minutes. You sit there and try everything. check here if you're already in it. You stay quiet. Stay quiet. We got a couple more minutes. Give everybody a chance to figure it out. Gina, I have I'm down to paper towels, but they are back there. Sorry. Yeah. Yes. You're just gonna read it, try to figure it out, go over it in just a few more minutes. Bless you. No. Some people are reading and they're working and they're figuring it out. We need to respect those people. So be quiet. Yo, just wait a minute. Just wait. I will go over it. We give people a chance to learn. Yesterday, lots of people trying to learn and lots of people trying to talk. It was not fair. Half this class was irritated with the other half talking so much. So we need to have quiet time for people. There's lots of people in here. Respect them all. No, Renee, just face forward. Don't listen to him. You were great yesterday. Him, on the other hand, still goofing on. Calm down. Read your book. Figure it. Lori, you can figure this out. Read your book. Just read it. You can do it. Rebecca? Yeah. Just sit there. I'll go over in a minute. Just be quiet so other people can read. Shh. Don't start a conversation. Stay quiet. All right, it's about 2 o'clock right now. I'll go over some of the information in this book, maybe till 2:10, and we'll see if you guys can stay quiet and interact like positively. Let's see what you got for 10 minutes of me talking. You guys ever been in a room or in a car with your little brother or sister, and you notice that whenever the parents start talking, they start like yelling at the parent and asking them questions? You ever seen that? Watch. Watch when you're around toddlers, 4-year-olds, 5-year-olds. The adults start talking, all of a sudden they got questions. Or you ever seen a little kid and their mom's on the phone? Then all of a sudden they have to know, they have to talk to their mom right then. What's happening in here is when I start talking, you guys start talking to each other. It's like there's noise. So you create more noise. So can you stay quiet while I'm talking? I don't know. Let's see. So we're estimating intercepts. When it says intercepts, there's two possible. There's an x-axis and a y-axis. So when I look at number 1 on page 189, I need to see the x-axis and the y-axis. Here's an x-axis. So I'm going to look and see where it goes through. It goes through here. You can circle it right in your book. This area here where the graph goes through the x-axis is called an x-intercept. And that's at about 1.5. I'm going to estimate. It's between 1 and 2, so it's a little bit of an estimate. Actually, if we wanted to like show it was an estimate, one great way to do that is with a squiggle equal sign. I'm estimating 1.5 there for the x-intercept. Now there's another axis, and that's the y-axis. There's an intercept on the y-axis. That's called the y-intercept. That's 3. You can say that y equals 3, or you can show it as like 0, 3, the exact ordered pair. Here you can see the textbook does it both ways. They do the point, and then they do the value. What's that? Well, this one is exactly at 2. Or at 3, I should say, so I can do that. But if it's in the middle, a squiggle's a good idea. Yeah. 1.5, 0. For the x? Yeah, like this is all the same information. The x-intercept's at 1.5. The y value is 0, so you would put a 0 in the y coordinate spot. All right, so in number 2, when I look at the x-axis, it never crosses. So there is no x-intercept. None. The y-intercept right here. I know is exactly at negative 2.4 because it tells me where the line is at negative 2.4. This is the y-intercept. You guys try to find the right answer on number 3. You don't have to find them all. But now that I've done 2, you guys try number 3. Braden, you did 3? Let's go. You guys done with 2? Good? So when I focus on the x-axis, it's kind of hard. There's a lot going on. We go through here, here, and here. There's 3 different places that this x-axis is intersected. I have to describe them all. I'm at -1. I go where x equals 0, and I go where x equals 1. So this is x -1, x 0, x 1. These ordered pairs are -1, comma 0, 0, 0, and 1, 0. Y-intercepts. Now, here's the y-axis. You got to focus your mind on the y-axis. The blue line goes through in one place. It's already circled because there happened to be an x-intercept there as well. So right there is an x-intercept and a y-intercept. And that's the origin, 0, 0. So yes, sometimes you can have 3 x's and only 1 y, or vice versa. I'm going to skip 4 and move on. Maybe you guys answer 4, I'll answer it. I did. I can show it at the end. These are a little more important, so I'm going to emphasize them first, but I can. Actually, a function will never have more than one y-intercept, and that's because of the vertical line test. But that's a concept. If you guys don't understand that, that's okay. It's kind of a really advanced concept there, the reasoning. It can obviously have multiple x-intercepts. This writing down here? Is that podium in the way for anybody? Alright, so the theme here is characteristics of functions and different ways to describe equations. So there's two things happening in this data. There's talking about positive, negative, increasing, and decreasing. If it's above the x-axis, you describe it as positive. If it's below the x-axis, you describe it as negative. No, it can be above and decreasing. Right here, where it's red, it's above the x-axis, so you call it positive, but it's going down, so you say it's decreasing. Hi. I think maybe just like right here. Okay, yeah. Thank you. No, your books can stay underneath, but the Algebra 2 books are going to go in there too. 150 of them. There's some 9th graders. It's mostly 10th graders. And then there's a lot of 11th graders too. It's a mix. Yes, it's an honors class. You did geometry after. Going uphill. So when you read or you walk left to right, if it's going uphill, you say it's increasing. If it's sliding downhill, you say it's decreasing. So it's an uphill, downhill concept. Uphill, increasing. Downhill, decreasing. So positive and negative is not the same as increasing and decreasing. You got it, Gina? They're not the same. Positive, negative, increasing, decreasing, they describe different things. Let's go to number 5. So we got to think about, is this positive or is it negative? So I'm going to break this down. Maybe I'll color it. And if you guys have highlighters, I don't know. In this red part here, it is negative down here. It's negative below the x-axis. Right, right. This is negative and increasing. Those two things can exist. It's like you're underwater, so you're in the negatives, but you're swimming up. So it's under, but it's going uphill. You can, but this right here is negative increasing. Yeah, you put, yeah. No, I have not really answered it yet. I'm still. So I'm gonna say it's negative. Watch this. Watch that. It's an inequality. We describe this with an inequality. Is that how that is? So it's negative, like to the left of 2. So I'm going to show that here, x less than 2. Everybody's looking at their phones losing points all the time, so stop. So I show this with an inequality, saying if you're less than 2 on the x-axis, you're in the negative zone. Positive. Above. So wherever it's greater than 2, when x is more than 2, it's positive. Listen, you don't need that type of comment. It's just disruptive. Nothing challenging at your age makes sense the first time you see it. You got to read it, think about it, let someone explain it to you more than once before you say it doesn't make sense. So be quiet with that comment. It's unnecessary. It's ruining the mood of the room. All right, so this is only part of the answer. I haven't even explained it completely. Here it's negative and here it's positive. I use inequalities to show that. Yeah, look at the directions say explain when it's positive and negative. That's one answer. And increasing or decreasing, that's a different answer. It's increasing. It's increasing for the whole graph. Because it's going uphill the whole time. Uphill is always increasing. Yep. Let's do another one. Number 6. Can you identify where on the graph it's positive? Draw it, you guys. Draw it. Draw an arrow where it's positive. Okay, so you totally get that. Let's just say, oh, I get that part. You're going to talk about the part you don't get. You're going to talk about the part you get. All right, so it's positive up here, and it's positive up here. You have to describe that some way. So I describe it, it's positive when x is less than 0, and it's positive when x is greater than 2. Wow, this really ties into compound inequalities. Over here where x is less than 0, it's positive. Over here where x is greater than 2, it's positive. This is an OR inequality. That's how we describe it. All right, now how would you describe negative? When x is in between 0 and 2, it's in the negative region. Here it's negative. I really want to do equal signs here, I think. It is really hard to understand in Algebra 1 why you got to break down these graphs, but in Algebra 2 currently, we are creating these. We're writing these equations and we're graphing these. And actually, second semester, we're going to draw these curved lines based on these numbers. So being able to draw it, you have to be able to describe it and understand it and pick out details. So you're learning to pick important details of graphs, which does feel kind of, but again, you are preparing for college in this and understanding graphs. So, all right, so that's halfway done. We got our positive answer, and we got our negative answer. So now increasing and decreasing. Laurie, have you got any of this yet? Could you describe for me where the graph decreases? Yeah. No, number 6. I'm on number 6. Gavin, go ahead. Yeah, so it's right here. Decreasing. No, just describe the x value. Yeah. Yeah, it is hard learning to describe it. So you guys, I think that you guys were okay for about 15 minutes. Because right now it's like 2:18 and lots of people are starting to comment and talk. So I gave you guys right now about a 15-minute window of instruction. And then we need to go back to silence. All right? So guys, turn your books. You guys made it through all of the instruction about intercepts. So go right into your assignment, page 193, and do 1 through 4. So you should be quiet. All right, so go to page 193 and you're doing your assignment, which is 1 through 8. You were quiet all the way through intercepts. The first half is intercepts. The second half, I think you guys got positive and negative. I'm not sure about increasing and decreasing. So do what you can. No, right now, you guys just be quiet and work. If you're talking, you're losing points. Don't lose them. But then you might not get credit for it, so check it when I check it. Just a moment, please. Stay quiet, stay quiet. Gavin, what's your question? Oh, you can, if you can, yeah. For positive and negative and increasing, decreasing, yes. That's not intercepts, but that's the bottom half. 1 through 4 is a different set of directions than 5 through 8. It doesn't say to write the inequalities. Is that what you said? It says when it says approximate, That means you have to describe it. So you can describe it with words. So for instance, like up here is positive, right? So you could say it's positive when you have to describe when it's positive. When x equals -5, -4, -3, and -2. Do you follow that? You have to tell the reader the location, right? Like we're not just drawing it, we're telling them where it is. It's positive when the x is over here. You see that? Now, this doesn't really show everything in the middle. So I would say when x is less than -2. This tells me it's everything over here. The symbol describes what the words cannot.